We've learned that according to the Bronsted-Lowry theory of acids and bases, an acid-base reaction occurs as the result of a proton transfer from an acid to a base. And we've seen how the dissolving of an acid or a base in water is actually an acid-base reaction. There is a specific type of acid-base reaction known as acid-base neutralization. Water, we know, can act as an acid or a base. Acid-base neutralization, however, occurs between compounds that always act as acids with compounds that always act as bases. So it's a little different than dissolving, where water can be an acid or a base. So here's a typical neutralization reaction where we have hydrochloric acid reacting with sodium hydroxide. Any compound that has hydroxide is a base. Hydroxide is always a base. Hydrochloric acid is always an acid. And when hydrochloric acid reacts with sodium hydroxide, we form water. Anytime hydroxide reacts with an acid, it forms water. And then it also forms an ionic compound. So this is known as a neutralization reaction. Another common neutralization reaction is the reaction of milk of magnesia, which is actually magnesium hydroxide. And as we know, hydroxide always acts as a base. So when that reacts with the hydrochloric acid in your stomach, it neutralizes the acid in your stomach to form magnesium chloride and water. And in this graphic, milk of magnesia has this milky look. That's because magnesium hydroxide doesn't dissolve in water. These are very fine chalky particles that don't dissolve in water. But when magnesium hydroxide or the milk of magnesia reacts with the acid, a reaction occurs that forms water and magnesium chloride, which is dissolvable in water. So neutralization reactions occur when an acid reacts with a base, and typically water is formed and an ionic compound.